Good morning, everybody. Welcome back to statistics and the next chapter section on what we call linear regressions. And we're going to take a look at if there's a relationship between a couple things or not. And for instance, one of the examples we're going to be doing is it's getting pretty warm out there. Do you think that an ice cream shop who sells ice cream is going to have higher sales when it gets warmer out there? Do you think people are going to flock to a ice cream store when it's hotter? Or how about when the temperature goes down and it's 30 degrees Fahrenheit, below freezing? Do you think people are going to go to as much and spend as much money at an ice cream shop? In that illustration, it seems like that there is a relationship between the temperature going up and the sales going up in terms of ice cream. Let's take a look at that. So let's share my screen, see how that's going to lead us to that conclusion. Before we get started, I'm going to take a look at, as we get started, I should say, we're going to take a look at something called scatter plots. And a scatter plot we're going to a place where it's been a while. Maybe if you had an algebra class recently, like maybe like within the last year, it'll feel like an XY axis, and which for the most part, that's what we're going to use is XY. And the X is going to be the horizontal axis and the Y is the vertical axis. And for the most part, we're going to stay in what's called quadrant one, where everything's positive. It doesn't always have to be that way, but for most of the examples, that's what's going to happen, and you'll see why. A scatter plot, okay, there's your ordered pairs. For each one represents an observation in the data set. And one of the measure variables that's measured along the x-axis, and the other one is along the y-axis. And so if you take a look at this next example right here, there's a bunch of dots, and it's representing car weight and miles per gallon. So what's the saying? The heavier the car, the worst, so you can see 10 miles per gallon, the worst gas mileage. Let's say it's a Hummer, one of those big heavy Hummers. Probably not going to get very good gas mileage versus something that's very lightweight. You're going to get something that's even better. That's what this is showing. Is there a relationship between the weight of a car and the gas mileage that it gets? That's what an example we're going to take a look at. And in this dot plot, what would there be? Maybe about 40 examples of cars and their weights, and someone went out and tested and see what the gas mileage was. They're all over the map in terms of this. But what you're going to be looking at is, does it look like it follows some sort of a line, some linear, they call it regression, some linear line. That's kind of a double. Linear and line means the same thing. Does it look like it's a line? No, it doesn't look like it's all lined up. But the closer they are to a line, the more of a relationship they have. This looks like there's some kind of relationship, and it looks like it's down to the right. And so you remember about slope. Slope of a line, if it's down to the right, it's going to be negative. So if you got a line that looks like this, the slope of that line is going to be negative. And if the red pen is a line that goes up to the right, that slope is positive. So anything that looks like it's going down to the right, we would say there's a negative relationship. If the dots are all over the place, which you'll see in some other examples, you'd say there's no relationship. And if there is a line of dots that's going up to the right, and they're pretty close to the pin itself, and you'll see a couple of those, then you might say there's a stronger or a strong positive relationship. I'll show you some examples in a second. Okay, now that ice cream shop keeps track of how much ice cream they sell versus what they call, we're going to look at just the noon temperature on that day. So how much ice cream they sold by noon or at noon, depending on how you want to look at it. It's not very detailed on that. So if you look at Celsius in this case, there's the temperatures. The higher the number, the warmer it is. So if I look at this, 22.1, looks like they sold $522. And if you went down to maybe one of the lower ones, like 11, it's a little cooler. Yep, see there's lower, less money. Higher, more money. 18 is warmer than that. Looks like it's warm. Looks like there probably is a relationship. Kind of makes sense too. And if you look at the bottom part of the graph right here, this is what you would expect to see. And I'm going to show you how to put this in your graphing calculator too. That the dots that we plotted. So remember, this is like X comma Y. 17.2. 17.2 is in here. And what was that? About $408. So it's probably right about here. And you plot that. And as you can see, there's a positive relationship because it goes up to the right, and fairly strong because it's fairly close to a line, fairly strong. Show you how to put this in your calculator and get the same graph momentarily. Okay, let's flip the page. Give you some other ideas about graphs. So as I look at this, up to the right, of course, down to the right. So positive up to the right, positive relationship. Okay, there is a relationship because it looks like it's fairly a good line, where if you look at the bottom, you see how it looks like a shotgun. BBs all over the place. No relationship. Can't tell if it's a line or not. Stronger relationship, negative. So this is stronger than that. This, see, the dots are closer together for a line. So that's your job in this section, is going to be able to, hopefully, by the graph, maybe guesstimate what kind of relationship, whether it's positive or negative or no relationship, and whether or not it's somewhat strong, stronger, and then, of course, no or even weak relationship. Some other scatter plots, positive, and sometimes they call it correlation. So instead of relationship, sometimes we'll call it a correlation, negative, and pretty much no correlation whatsoever. Zoom in here so maybe you can see this. Very strong. They call it perfect. Perfect because every single dot lines up. Remember the equation y equals mx plus b, slope-intercept form. We're going to learn how to find that as well from the calculator. High positive correlation, positive up to the right. That's super strong. That's kind of strong. This is low. It looks like there's a relationship, positive. That's weak or low. When it says no, it's hard to see, but you'd see there's dots maybe all over the place like this. And then this one is low negative. So the dots that I'm kind of plotting kind of looks like this from what I can see on my sheet. Higher negative relationship, and then perfect means that all the dots are lining up. You can connect the dots, and you've got an actual equation that would help you do that too. And so here, in this page here, we've got, if we know that there's a relationship and we want to try to make that determination if there is or not, we're going to look for something called the correlation coefficient. It's a number, and it's found by, that's a crazy equation, isn't it? It's found by knowing what all the variables here represent. And most of these, actually all of them, you know what they mean. X bar is the sample average of all the X's. So you just add them all up and divide by however many you got. And we've done something like the difference of what each individual from the averages. And same with the y's, you do the same thing. You find y bar by adding them all up and dividing by how many you got. Whatever the sample size is, and it'll be the same for x and y, it has to be. And little s's are the standard deviations for each of the x's and y's. And of course, that symbol right means you're going to add them all up. So there's a lot going on here. To do this by hand, forget it. So we're going to let the technology find us the R. And so we don't have to do it by hand. And I'll show you that with the calculator instruction sheet here momentarily. So once we find the R, once we find that number, then we're going to compare it against a range of values. This has been set up ahead of us because we had to have some kind of threshold. I mean, you might remember it said strong versus weak. Well, how do you determine whether it's strong versus weak? So we're going to have a number. And as you can see, there's 0.7 here. This is what our author in textbook will use as 0.7. 0.33 to 0.07 is going to say there's mild or maybe weak. You could use the word weak in here. There's a positive. You might use the word strong in here. There's a strong, mild. Maybe you can say weak. If it falls, if the number falls between these two values, then we're going to make a decision that really is no relationship that we can determine. And on the other side, we're going to go mild or weak, and there is a strong here, strong negative relationship between the variables. Okay, let's take a look and see how we can find that R. Going back to the ice cream, and I want to have you get out your, towards the back of your packet, there's calculator instructions. Now I'm going to cover this up for a second. The only ones that I really want to take a look at right now is up here first. And I'm going to follow the instructions with the calculator, step through it with you. So to set up a display, to display the correlation coefficient, and this instructions you only have to do once right here. So turn on your calculator, press second, which is the blue, and the digit 0, which is down here, and you can see blue, it says catalog. So press second, catalog. And then what you can do is scroll down to where it's called diagnostics on. So I'm going to zoom in here so you can see this. So I want diagnostics on, and it's alphabetical. So here's the A's first. And this is a catalog of features or functions that the Texas Instruments 84, even the 83 has. So I'm just going to keep scrolling. Oh, remember that binomial PDF? We saw that before in a different place. Keep scrolling down. I'm looking for the D's, getting closer. Okay, now I'm in the D's. I'm looking for diagnostic. Keep going. Okay, not the off. I want the one that's on. I want that one right there. So turn that one on by hitting enter twice. Once, twice, and it says done. So make sure you do that. Now, once you've done that for our course, you don't have to do it again. That's it. You're all set. So now the next step is you want to find where we have to edit. We want to go back into entering the data. And when we do that, stat, remember it's under edit. We've got list one, which typically that's all we've done in the past is just go into list one. But because we have two different variables, we're going to do list one and list two. List one is the X, list two is the Y. And I've already entered them in your calculator. And again, what did I enter? I went, go back to your ice cream sales. I entered these values. And as you can see, it looks like 14.2 and 215 are related right there. So enter all those as I did up to, there's 12 values. Once I've entered those, go back to the instruction page right here. So right here, I'm at this stage. After I entered them all into list 1 and list 2, I'm going to go back to stat. So I'm just going to press the stat button, which is right down here. And I'm going to head over to calc. And then I'm going to go down to either lin-rig, that's linear regression, lin-rig, either the AX plus B or the A plus BX. I'm going to choose this one, and there's a reason for that coming up here pretty soon. I'm going to choose that one. So there it is, number 4. It's the closest one anyway, but I'm going to choose it. There's a reason behind that. Well, I guess I might as well go ahead and tell you. In the old algebra days, y equals mx plus b, mx plus b. This is the equation of a line. As you remember, the b is called the y-intercept. So that b is the y-intercept of the line. And m represents the slope. Well, this calculator says a represents the slope. So this is y equals ax plus b. A is the slope. That's the steepness of the line. So it feels better than doing this one where the b is looking like the slope instead of the y-intercept. So choose that one. Hit enter. And make sure that list 1, it's high, and it should be highlighted as list 1. If it's not, then email me and then I'll help you find what list 1 is, where to find that. And it's, I can tell you right now. If it's not saying list 1 right there, there it is, it's blue. You can change it. And there's list 2 if you needed. So always make sure that X is list 1 and Y is list 2. Leave the frequency off. Don't even worry about that. Look at the calculate. So go down here. And as you head over to calculate, on this one, press enter, 2 names. If you hit it again, it's going to show you a bunch of stuff. Okay, you see the equation of the line right here, y equals ax plus b. This is your slope, and this is your y-intercept. And I'll show you what we're going to do with that in a little bit. Don't worry about r squared. There's your r, and I'm going to write that down. So r is about 0.94. Our r is about 0.94. Our r, squiggle, squiggle, is about 0.94. Which, if you go back to the inequalities that I showed you earlier, remember these inequalities? Okay, now let's see, that's positive, so it looks like there's a positive relationship. And since it's bigger than 0.7, there's a strong positive relationship. And if we were able to do this, the dot or the scatter plot, then you'd see that the dots would line up kind of close into a line because it's almost 1. By the way, 1's the threshold. 1 would be perfect. If it was a positive 1, it can't be any more than 1. So if it was 1, it's perfect relationship. So this is a strong positive relationship between the two data values. Okay, what I'd like you to do is go about 2 pages further in to this one, and we're going to wrap up this particular problem, show you how to find the equation of the line. So go back, keep going, flipping through the pages, and notice that we're at the same ice cream versus temperature problem. And if it looks like there's a relationship, which it does, because it was strong, it was 0.94. And then what you're going to do is, now this looks funny, don't worry about that. Ours is going to be y equals ax plus b. And for us, don't worry about these guys. Not going there, we're going to go y equals ax plus b. From your calculator, back to the calculator, here it is. I'm going to go ahead and let's do 2 decimal places. So y equals, okay, the a is 28.15x, and that would be minus 131.67. So what's this saying? Well, if the temperature was 0 degrees Celsius, remember X is in terms of temperature. The temperature was 0 degrees Celsius, which is, gosh, what is that, 32 degrees? That's freezing, 32 degrees Fahrenheit. It's saying that at noon, you're losing money. Somehow you're losing money, negative $131.67. For every temperature that it increases, you're earning about $28.15. So really, this is money. What was it? 18 degrees Celsius back over here, about 18. One of them was 18.1. Should have about 421 bucks. If you put 18.1 into this equation right here, 18.1. So if I go 28.15 times 18.1. So again, what am I doing? I'm taking $28.15 times the temperature, 18.1 Celsius, and subtract $131.67. I should get pretty darn close to that dollar amount on that other page. So $377.85. Now, when I look at this, we're off, as you can see, and we're off for 2 reasons. One, I rounded that from the original. I rounded it. So you're going to be off a little bit because of that. The reason why it's off so much is because it's not a perfect relationship. 0.94 is not 1. If it was 1, then the answer would be spot on. If the correlation coefficient was 1, it would be spot on. But because it's off, my dollar amount would be close, but it's not perfect. And then if I want to predict about how many dollars that I might earn at noon on any given day-ish, based on the data, and let's say it's going to be a stinking hot day and it's warmer than, well, 25, it's warmer than 25 Celsius. Let's say it's up to, I don't know, 28 Celsius. I don't know, how hot is 28 Celsius? There's a conversion formula in terms of Fahrenheit. I would just say it's, instead of 18, it's 28. So $28.15 times 28 Celsius, and then subtract 131.67. I should have around $656, $657. It should be more than this, right? It should be more than that. That's the highest. And that's what I am trying to do, is predict about how much money I would either make. All right, let's do one more of these problems that I've given you. And just to remind you how to find the correlation coefficient and make a determination. But before that, I want to show you how to create your dot plot. Remember how that looked earlier? Hello, it's here somewhere. Relationship. I know I've got it here somewhere. All right, I think it's right here. Remember this right here? I want to make sure that I can see that. So here's what you'll do. I'm going to set up my X and Y axis. And I'm going to end up going window for this, by the way. Set up my X and Y axis, and it's based on what you see right here. Now, I don't see any negative X values, no negative degrees. And it looks like the lowest was, what, 11? Let's go down to 0. So minimum is 0, and that's even showing in the graph anyway. Go down to 0. And then let's go as high as 26 degrees, because see, 25.1 is the most. Let's go as high as 26 degrees. So let's go as low as 0 and as high as 26. And let's go, they're showing markers every 2, jumping by 2. So let's make the X scaling by 2. And then the Y minimum is $0, not making any money. And then as high as $700, because the biggest dollar amount was looking like $614. So let's make this 700. 0 to 700. And it's jumping by every $100. So the Y scaling right here, make it 100. All right, now the next thing is we're going to go and turn on our plots. Now, previously, we've done a dot plot, which was a probability dot plot. That's different than what we were looking for. Let's go back into our plots that we've done, which is stat plot. Let's go into number 1. Stat plot. Let's do number 1. And I'm turning on stat plot number 1. You in the past might have had that one in the bottom right for the dot plot. This is the one you want to have highlighted. And mine's already there. If it's not, just go to the first one and hit enter. Okay, now, I'm going to choose that mark right there. Go back into, do second quit, get a clear home screen. I'm going to turn it off again for a second. Give me a second, turn it off. And the next thing is I want the plot. So let's take a look at the instructions over here. One more time on your instructions. If you remember the instruction sheet that I had before. And I'm finding it for you. So to graph a stat plot or scatter plot, after you've run the regression, go second y equals plot, which I did, and you select it on, which I did, choose the first graph, which I did, change the defaults. So now we're going to do a press y equals, and then we're going to clear out any other lines that we have entered here. So get rid of all that junk right there. See, I have stuff there, so I'm going to clear that out so I don't have anything. Now move the cursor. It says enter all the lines, make sure they're gone, clear. Move the cursor to the space following the Y line. So, and from there, press vars. So what we're going to do is see where the cursor is right here after that. Now press vars, which is right here. vars, choose statistics, choose statistics. So how did I do that again? I went press the vars, choose statistics, and where I'm at right now, I chose statistics, and then choose the EQ right here. And then choose the REG, that's the regression equation, which is the first one. So press enter. And I'm going to try that one more time. I want to make sure that I had this in my calculator already. So let's go back because I've already run the regression and I had done something differently because I noticed those numbers are not right. So clear that out. Go back and make sure I run the regression, meaning I'm going to go find the correlation coefficient. So where I found the correlation coefficient is I did stat, calculate, linear regression right here. So now I'm going to go back is the vars. Go down to stats, statistics, the equation, so I'm going to go y equals stats, excuse me, vars. So I'll go y equals vars, statistics, equation. And if I look at the arrow right here, you see how that's got those values that I saw before, lots of decimals, so lots of decimals. So I probably had it already in there before, just had a bunch of weird decimals. And now if I want to go here, after I've done that, you're going to go back over here and you're going to go zoom, stat, zoom, stat. We've done zoom stat before. And that's the regression line, but that's not the stat plot. That's the regression line. That's not the stat plot. If I want to see the stat plot, see, it got turned off right there. I want to see the stat. My stat plot was turned off. I was looking for the plots. I had to turn it back on. I should be able to now do zoom 6. Let me try that again, one more time. I'm going to go back, look at my window. Oh, my window screen got all changed. And if you remember, I need to make sure that that is from 0 to, let's see, the temperature was up to 26 and scaling of 2. And this is money 0 to $700 and $100 here. And so what I'm going to do is make sure my Y equation is there. And I'm going to end up doing zoom 9. And finally, I got my stat plot with the line that goes, what's called the linear regression line. That's the y equals mx plus b, but there's your stat plot that I wanted to make sure that it was matching up with what we had here. And it throws the line in at the end. Then if I want to predict anything, like what's the equation or the value if I used my equation down here, which I've already done for you once. This is the equation of the line. And I said, what about the temperature? If the temperature was equal to 28 degrees Celsius, then you go y equals $28.15, 28 degrees, and subtract 131. Subtract 131.67. We're at that $656.53 value, $656.53. And if I want to find the 26 degrees, you would do the same thing to predict the dollar amount that's earned. Here I'm doing 28 degrees, and if you wanted to find 26, you can replace the X with 26 degrees. Okay, one more problem, and just to find the correlation coefficient. Let's take a look at this problem. Let's find if there's a relationship, so we'll find the correlation, the relationship that scores, math scores, and their heights. Is their relationship with a person being high, tall or short, and their scores. And you would think that's silly. The person who's taller is going to get a better score, or vice versa. The person who's taller is going to get the worse score. So you'd think there's no relationship, but we're going to use the R to determine it. So to put in the values, we have to go back to stat and edit. And we're going to have to put in, this is my X and this is my Y. This is my list 1 and this is list 2. So I'll get rid of all the stuff in the list by clearing it all out. And now I'm going to put in all the values in list 1. It's going to take me a few minutes as I type this in, hopefully not making a mistake. Easy to do sometimes. Human error. Pressing buttons. Okay, looks like there's 10 of them. And over here, I toggle over and I'm going to put in the percentages for each one of those X values. And so 56, 29, wow, that's a failing grade. This person, that height is going to get a failing grade. Yeah, well, I don't know if there's a relationship or not. 67, 38, 85, 77, and finally 56. I haven't. See, now I've typed in something and I missed something. So I have to go back and try to figure out where I missed. Okay, 195 and 93, that looks good. 67, 185 and 38, 166 and 85, 173, 56. Oh, I just have one more and make that 71. So that was not an issue. So now the next thing you want to do is you want to find the R. So all you have to do is, I went second quit, is go into stat, calc, and that number 4, linear regression, hit enter, keep going down until you get to the calculate. And there's our R, which is so R is around 0.21. And which this is meaning from your packet page about the range of your making your decision. 0.21, well, it's positive, but it's in between here. So there's no relationship whatsoever. And if you did a stat plot and you did a scatter plot, you'd find out that the dots would be kind of all over the place. So you'd say no relationship. Because R equaling 0.21 is less than 0.33 and greater than negative 0.33. No relationship. And let's see if we can do this in the calculator to get a stat plot. I'm going to go back and set up my y equals. Okay, there's I want this different equation that's in there. Actually, let's not even do an equation. Let's just clear that out and let's just do the stat plot, no line. And let's go into the window and we're going to go from X values. Let's go from 0 to maybe 200 centimeters, 0 to 200 centimeters, and let's jump by maybe 10 centimeters. Y minimum percentage, well, let's just do 0 on that and go as high as 100%. And let's jump by 10%. And now let's do zoom stat, that's zoom 9. And you see how it looks like maybe a little bit of positiveness going up to the right, but because it's not close to a line, we're just going to say no relationship based on the picture. Okay, so for the homework that I gave you, the problems, it should be, we have enough information to give us help by working out those problems. And you can take a look and see what the author's done for the what they put in the problems to help guide you. So that's it for me today. That's 4.1 and 4.2. And until another time, be safe. Take care.